So we've got hopefully a quick set of notes here. I'm just going to start from the beginning because I don't know how far some of the classes got, so you may have to fast forward a little bit if you want to. So we're talking about distribution, center, shape, and spread. How can you use the mean and standard deviation to describe the center and variability for distributions? A lot of us did this warm-up in class already. So if you recall, when we were trying to find the mean of the data, we found the sum of all of these values and then divided them by 10 because I have 10 students total in this sample. So the mean of this data we had determined was 42. And then what does the mean represent in context of the data? It represents the average study time per student for this math test. So once we found this information, we then analyzed it a little bit further. So going on to the next slide, we talked about standard deviation, how it is the measure of spread or variability in a data distribution. Basically, in everyday language, this is just saying that it's the average distance that each data point is away from the mean. So the average distance away from the mean. A small standard deviation would mean that the data points are very close to the mean or to the average of that set of data. A large deviation indicates that the points are very spread out over a large range. So when we looked at this dot plot, this study time was the time that was provided in the previous or in the very first slide. So it's just a visual representation of all of the data sets, and we had determined that the mean was about 42, so we'll say, or it was 42, and this is not a straight line, but it's approximately in this area. So using what we determined with the standard deviation, and I gave you guys little slips on how to calculate the standard deviation. If we calculate the standard deviation, we determined that it was 8.77 for this study time data that we were provided, which means that each of these points is approximately 8.77 units or hours in this, or I'm sorry, minutes, away from the mean for the most part. If we look at data set A, you can see that we've got data points that are very far spread out, further apart than the previous set of data. So in data set A, my standard deviation would be greater than 8.77 because of that large spread that we've got. For data set B, you can see that all of the data points are very close to this mean. So in this case, data set B, I would say that the standard deviation should be less than the 8.77 that was provided, or that we calculated. Data set C looks very close. It looks like 8.77 would be almost correct, except for the fact that you can see we've got data points a little bit further out than my original set of data. And then over here as well, it's just a little bit further out. So I would say based on the spread, this would probably require a greater standard deviation just because the data points are just a little more spread out away from this mean than my original set of data. So going on to the distribution shapes, and you can refer to your packet for a summary on the distribution shapes. On the very front of your packet, it has what the distribution shapes would look like in terms of histograms. And so the key words here would be symmetric. So it's symmetric if the left and the right side roughly mirror each other. The distribution would be mound-shaped, which is another way of saying symmetric, except for the fact that a mound-shaped distribution has a single peak in the middle, and you can see that again on your packet, the homework packet. It's the very front page. A distribution is skewed, so this would be another key term, if it has a noticeably longer tail on one side than the other. So it would be skewed to the right side if there is a longer tail to the right. And so by a longer tail, I mean that there is more spread out data points towards the right, whereas there's a clump or a cluster of data on the left-hand side in this case. And then a distribution that has a longer tail on the left and more data on the right would be considered skewed to the left. Again, you can refer to your homework packet, the very front page for that, for a visual representation of that. So looking at the next slide, we've got example 1, and this is part of the notes that I printed out for you. So I'd glue this into your notebook. The histogram below shows the distribution of battery life in hours for a sample of 40 batteries of the same brand. So what does the width of each bar represent? So you guys have seen bar graphs, but you've also probably been introduced to what a histogram is. And so in this case, we're dealing with a histogram. So each of these bars, we can look at the width, and since the bottom says that this represents battery life in hours, I can say that the width of this bar, since it goes halfway between the 80 and the 90, each width represents 5 hours of battery life. So when we look at the height, though, we can see that on the left-hand side we've got a relative frequency. So the relative frequency pretty much means that this is the percentage of the 40 batteries that fall within this category. So for example, if I took a look at, let's say, this bar right here, I can see that there are approximately 5% of my batteries, so 5% of these 40 batteries that were in my sample, and the 5% will last anywhere between 85 and 90 hours. So the height represents, like I said, a percentage of my sample. So again, I would definitely add that to the notes that this bar in particular would represent 5% of the 40 batteries lasting between 85 and 90 hours. So, and this is just saying refer to your handout, so you can just fill that in your handout, glue it in your notebook for future reference. So looking at the next slide, I'm going to give you guys this as a warm-up in class. So I want you to take a few minutes to analyze this histogram. I don't think that this is on your note-taking guide. And it's because I'm planning on doing a quick poll and we could talk about it together in class to see how we do. So looking at this data, it represents the greatest drop in feet for 55 major roller coasters in the United States. So I want you to look at this and determine the mean of the drop. If you think the mean is closer to 90 feet, 135 feet, or 240 feet. So again, put this in your notebook. This will be what I'm going to check on Monday as your notebook check and also as a quick poll warm-up. I also want to know if you think the standard deviation of the maximum drop distribution is closer to 40, 70, or 100 feet. So again, take a minute to just look at this graph, analyze it, see which of the following you think best applies for the mean and the standard deviation, and we will talk about it in class on Monday. Going on to the last slide, we've got example number 2, and this one is on your note-taking guide, so I will work this one out with you all. The histogram below shows the distribution of gasoline tax per gallon, yes, for the 50 states and the District of Columbia in 2010. Describe the shape, center, and spread of this distribution. So looking at this distribution, since I have a large frequency of data over here on the left-hand side, I would say that this shape looks like it is skewed to the right because of this tail of data that is, I have a low frequency of data on this side. So I'm going to say skewed right for this shape. When I look at the center, I want to find, again, this is the mean. This is another way of saying the mean. And so when I look for the center, I want to find the approximate center where the data frequency on the left almost matches the data frequency on the right. And so looking at this, I would probably say that a good mean would be somewhere in here. And drawing this line, I can see that the frequency over here matches almost the frequency to the right. Not exactly, so whatever you all think would be fine, just as long as it's somewhere within here. So I'm going to say that the center is approximately 25. And then so looking at the spread, This is another way of referring to the standard deviation. So I'd say in reference to the center, I've got a high frequency of data that is within approximately 5 to 10 deviations from the mean. So looking at this side, it looks like 5 would be a good deviation, but then over here on this side, this is significantly lower. So looking at probably these two bars, I would say that most of my data set on the left is within here. Most of the data set on the right is also within this 10 cents per gallon. So I'd say that the standard deviation, or the spread, is probably or approximately 10. And again, this would refer to your judgment on some of these, but it looks like it would, as long as your answers are somewhere within these areas, then you do have a pretty good understanding of these. So try your homework assignment. If you have any questions, we will answer the questions on Monday. Otherwise, we're pretty much done with our probability and statistics section or unit. So now we're going to go on to logarithms and exponential functions so you can see that prior to spring break. So I will see you guys on Monday. Have a good weekend, and let me know if you have any questions. Also be ready to answer the quick poll that I left you guys. So this we will answer in class as a warm-up, so be ready for that. All right, have a good weekend. Bye.